Okay, thank you. My name is Tamar Kashti, and I will talk about artificial intelligence and how does it recognize objects without the need of a human in the process. So let's start in why do we need to recognize objects? When we look at our world, we recognize objects all the time. We see the people, we identify cars, and if we want a self-driving cars like you saw before with Odelia, we want them to identify what is in the road. So let's look how a car visualizes the road. It sees the road itself as purple, the cars are marked in red, the pedestrians are marked in blue. This is called segmentation. We divide the image into objects. And this is the basic model that enables us to understand what is in the image. How do we get machine learning or artificial intelligence to learn what is an object and to identify it? They learn from a large set of examples. So let's say that we want a model that identifies monkeys in images. So we take lots and lots and lots of monkey images. No animals here in this airport. And so we have lots of monkey images, and we need someone to mark them, usually by hand, one by one. So we have our research associate, and she works one by one to mark this red curve on all the monkeys. And why do we need that? Because we want the network to learn from those examples. The training process is when we take a model, we put an input image, and the model have a guess of where is the monkey, and it compares our human annotation to its guess, and if it's not good, it improves its internal parameter until we have a good guess here. So it's a good process, and it works fantastically, and that's how most of the AI work nowadays, but it has large disadvantages. The first one is that it's very time-consuming. There are people making a living just out of all those markings. The second is that we have mistakes, and mistakes affect our accuracy. And the third one is, what about zebras? I marked all the monkeys, but my model will not know how to mark zebras, so I need another thousands of images, and the person which will mark me the zebras, and all the animals alive are, well, and we have many of those. So it's not efficient. We would like to take out the man in the loop and to make our models learn without any human. So how do we do it? We take our inspiration from the way people learn language. People learn language from the context. They have a sentence, they don't understand one word, but we understand it just from the entire sentence. So this is the revolution that happened a few years ago in artificial intelligence, and it started from text models. Those models, the large language models, they took sentences from the internet. For example, the boy went to the lake. They took out one word and gave the model to learn how to fill the gap. Now we don't need any person in the loop. We don't need it, so we can take millions of sentences. And this is how ChatGPT works, by the way, because they fill in the next word. And it takes, instead of one sentence, it takes a full article and fill in the next word and the next word. So it's a wonderful way of learning. And we don't need any people limiting our amount of data. We want to take this, so in the last 2 years, people took this idea and inserted it into images. How do we do it? We take our monkey and we remove a part of the image. And our model will need to learn how to fill the gap. While it learns to fill the gap, it's not limited by only monkeys. It could be any image. We can take lots of images. We're not limited. And during the process, the model learns what is important, and now I will get a bit into the model. It divides the image into squares, and for each square, it creates a list of features. It describes, for let's say the first square will be described in our model as the leg of the monkey, because it knows that the monkey is the important thing here. So we have a list of features. It's a vector, and using this list of features, we would like to find out, to segment this monkey and to identify its tail. And there are, well, I need to tell you that those models are in the process. So we are looking at existing segmentation models, and there are a few of them, and they keep improving. So if we look at segmentation model when the human is inside, they are incredibly successful. We get 90% of accuracy. Those models are around, I don't know, well, the first one was 45% of the images were correct, but we are improving. So existing segmentation model take those model features and they get to 65%, something like that. We take the input image, we look at each square in it, we calculate the model features from those large models, and then we calculate the similarity between the features. What do we mean? How much do the squares resemble each other? If square 1 and square 2 are very similar to each other, that means that they are both on the same side. In this case, we would like to find whether it's the background or the foreground. The foreground is the bird. The background is the sky. And if they are both similar, it means that we know that they're on the same side. So we would like to, so we use the similarity and create a graph. This graph takes every square and turns it into a node. And if the nodes are similar, they get a strong connection between them, an edge. If the nodes are not similar, they don't get any connection or they get a weak connection. And our aim here is to cut the roof. If you saw this, if you're playing this game, we want to cut the roof where it's most easy, and find out what is the segmentation. So those are the existing methods, and they get to 65% of accuracy. And we want to do better. We look at the disadvantages of current models. First, they have low performance. It takes like half a second for each image because we have some matrix multiplication here. And second, you learn only from one feature, the similarity between the patches. When we had a full information of the features. So our idea, our new idea was using the full list of properties. We take all the properties of each one of the squares and insert it into our graph. And then find out the edges from, we want to find out the edges from the full description. It's like now we're not looking at are those sky close to each other, but now we have a feature like, oh, this has fur, this is wings. We have much more features that we can use to find out what is the true, the best separation. But now when we have more features, we need something smarter there. So we insert another model into our calculation. And from that, we can get a good segmentation. I will not get into the more details, but you're welcome to ask me. I will show you some results, which is more fun. So in the first row, you see the input image. And in the second row, you see the segmentation. So airplanes are easy, like the birds. But baby, the baby picture is more difficult because if you look at his clothes, it's very similar to the pillow that is near it. But our model understands not only from the similarity, but from all the features of the clothes, that the clothes is part of the baby and not part of the background. We can also do part segmentation. It means understanding the parts. So those are, in the first row, you see input images of birds. In the second row, you see one of the existing methods. And on the third row, you see our method. You can clearly see that we have the same color code. The background is always blue. The tail is always pink. So we can understand features better. You can also see that we are more accurate because the tail here is accurately segmented and the beak of the third bird is much more accurate. It is also 2.5 times faster than previous methods. So what are the next steps? The next challenge is going to medical images. Our lab, sample lab, is working on AI for medical images. We would like to have segmentations created not only by doctors, but also by the computer, which will enable us to use more data and get it much faster than our current process. So this is an example of breast cancer, and we would like to identify the segmentation, the tumor in this image, and this is work carried on right now in the lab. So those are my collaborators, Amit here, Shai there, Yonina, Professor Yonina Eldar, the head of sample lab, and I want to take my lab, that part of it is here, and thank you.